this video, I'm going to explain how to use biometrics in math or science classes. And I think you'll find that it's a little bit strange, but it's going to be very helpful. I developed this system to solve 4 fundamental problems that I encountered teaching physics all the time. Biometrics. The first problem that I encountered was that the physics that we were teaching in a textbook didn't have relevance to what students were learning, what students experience in the physical world, which is strange when you think about it. The second problem I had was cheating. You assign a bunch of problems, everybody has the same problems, one person does it, other people copy. If it's out of the textbook, people just look up the answers online. That was a big problem. The third problem is students would make an error and get a ridiculously large or small answer, but since they couldn't relate to what they were doing, they wouldn't detect the error. And the fourth problem, which was a uniquely American problem, was that students were not familiar with the metric system. With this biometric system, we address all 4. And the way it works is that all your numbers that you use in your equations are based on the human body and other things that are unique to each person, like their pets or where they live. So let me give a small, quick demonstration. Among the measurements we use is height. So this is my daughter. She's a different height than me. And let's see where her measurement is. Let's see, she is 52 centimeters, or 52 inches. Standard tape measure, so go ahead and write up 52 inches.
I thought it was 53.
Well, maybe you're slouching a little bit. And by the way, have people do it a couple times, because the fact that they're going to get different numbers can lead into a great lesson about accuracy and precision in your measurements. So the fact that somebody does it once and they get one number and they do it again and they get a different number, that really helps students understand that measurements are not always precise. So 52 inches, and you're going to measure me. We have over here a chair, and here's a tape measure, and now, by the way, all is good to measure across the back. It's straighter, and you're going to have less awkward issues of people brushing things that maybe people don't want touched. What is my height?
75 and a half.
75 and a half. So we have 2 different measurements. So, for example, 75.5. You want to convert inches to centimeters. Give everybody the same problem. Everybody does the same thing. Multiply by 2.54. And what do you get? So, I have 75.5 times 2.54 equals. So I get 190, well, there's 3 sig figs here, so 192 centimeters. That's my height.
No.
Oh, it's the solar panel. You gotta make it face the light. Did you want me to do it?
It's 1, not 2.
I was rounding. So 53 times 2.54 equals. So you'll write down the answer. Now, we both had the same question. We both got a different answer. And this is going to be very helpful. For one thing, you can't copy off your neighbor. You can work together with your neighbor, but you can't copy. You have to actually do the work. Another advantage is these numbers, we're going to use them again and again. For math, you could say, well, okay, what is 5 times your height? What's half your mass? And everybody gets the same question. Everybody will have to do the same thing, but everybody's going to get a different answer. You can't copy. And physics is very helpful because, for one thing, people are going to start thinking about their height as being this many centimeters. If you include having their pets measured, their cat is this many centimeters from nose to tail. Their height is this many centimeters. Their distance from the distance between their home and their school is this many kilometers. The numbers become real because they'll be using those numbers, those very real numbers from their lives, again and again and again. They will become very real, so they'll become very familiar with the metric system. And also, when you start taking mass and multiplying it by the force of gravity and distance to figure out the work, climbing a set of stairs, joules will become real, because they will know that this staircase that they climb on their way to English class every day, that they expel 4,000 joules going up it. Power will become real. Their kinetic energy running full speed will become real. The numbers will become real to them. They'll become much more familiar with the metric system, because they're not just a bunch of numbers coming out of a textbook. They are numbers that relate to them. You don't get crazy wrong answers. If there's a question about, how much energy do you require to get out of a chair, and somebody comes up with 50,000 joules, they'll know it's wrong. They'll look at that and think, no, that can't be right. There are other uses, but I have found it to be very helpful. When I started using biometrics, it was a little bit rough at first because the students had never been asked to do anything like this before. But most of the problems with the metric system, the problems with grossly wrong answers, the problems with copying, and they all went away. And most of the students told me they really preferred it that way. They found that the stuff was much more relevant to their own lives. And hopefully it can be relevant to yours. I'm going to create other videos because there are biometric ways to deal with volume, to deal with mass, work, power, even frequency, and for when you do chapters on waves. So I hope you've enjoyed this video, and I look forward to showing you how to do this stuff in the future. Say, stop messing up. Press it.